All right, this video looks at writing equations of lines. This is 3-4, 3-5, okay, right in there. Last section on the Chapter 3 test. All right, so I want you to get the handout on this from document sharing in my math lab. I'm going to be working through some problems off of that handout for you, okay? I'll also, I think, go ahead and post the answers to it when I'm finished, okay? All right, so the directions on this say to find the equation of the line satisfying the conditions and then write it in slope-intercept form. So what's going on here is it's kind of backwards from what we've had in the past. Rather than starting with an equation, we're starting with information about our line, okay? So these first three problems on the handout, I'm going to write down, they kind of go together, and I want you to kind of see how they're indicated. Okay, so the first one says with m equaling -8/9 and b equaling 3. Second one with m equaling -4/5 and passing through 0.6. And the third one gives you the slope of 2 and tells you the line passes through the point 0, 0. Okay? All right, so let's take a look at these. All right, so with these, what you can do on these is you can use the fact that they want the equation in slope-intercept form. So that means they want your final answer to look like y equals mx plus b with something where the m is and something where the b is. Okay. Now these three are a little different from the harder ones because they actually do give you the m and the b. So you're thinking this is what you're trying to get. And do you see how they give you that m is -8/9 and b is 3? This one, you would just write your final answer by plugging in the -8/9 and plugging in the 3. The mistake people typically make is they don't include the x. You're replacing the m with -8/9 and the b with 3. That's slope-intercept form. Don't forget the x, okay? Now, that worked that simply there because they explicitly gave you the b. Right now here, they didn't use the letter B, but if you think about the point 0.6, wouldn't it be on the y-axis up here? So that really would be a y-intercept. So if you notice that, then you know B is 6, and so it turns into the first question. And we can plug in a -4/5 for the m, so we'd have -4/5 x, and plug in 6 for the b, and there's our answer to number 2. Okay. Now with the third question, the point 0, 0 is pretty special. It's right there at the origin, isn't it? And so that one's a little weird because it's both an x and a y-intercept. So this right here is really the b. And see, this is happening only because the x on these points had a 0 in the first spot. So that put the point on the y-axis. You have to be sure of that if you're going to use this shortcut. So we can put in the 2 for the m, put in the 0 for the b, and then just simplify that. So y would equal 2x would be our final answer on that one, because plus 0 doesn't really change anything, okay? All right, let's look at the next two, okay? So question number 4 on the handout actually gives you a graph. And it's kind of a small little graph, so it might be hard to see. So when I'm looking at it, I'm noticing that it appears to cross up there at 5, and then it looks like it crosses at -7 when I look at it. Okay, so it looks like it crosses over there, and they just labeled this to be -5, this was 5. And that was -10. And so you had to kind of look hard on this one. It was a little harder to tell, but that appeared to be at -7. And so they were asking you to write the equation of this line right here that they graphed, but they didn't tell you anything in particular. So for that one, you should be thinking, okay, I'm looking for y equals mx plus b. I need the m, I need the b. Just have this graph to go by. You notice that little spot right there where it crosses the y-axis? Okay, isn't that the y-intercept? So it crosses the y-axis at a +5, so you can just put a 5 where the b is. All right, now for the slope, since you've got a graph, if you remember from the previous video or from class, if you've got a graph, just count to find your slope. Just think about trying to determine the ratio of the rise over the run. So from here, I can go up 5 units, and then I can go across this many units. So I can pretty easily see that's up 5. This to me was a little harder to see. It looked like it was crossing the x-axis at -7. So from there, I would have to go to the right, what appeared to be 7 units. Okay, what that means is the slope would be 5/7, because the rise, the vertical change should be on top and the run should be on the bottom. So put that in where m is. Don't forget the x. That's one of the most common mistakes. And there you have it. There's the equation of the line. Okay. All right, let's look at number 5. So with number 5, the variation on this one is they didn't give you the graph. They gave you the 0.97. They didn't give you the slope either, though. And they gave you the 0.0 -4. They didn't give you the graph, and they didn't give you the slope, and they didn't tell you outright what the y-intercept would be. Okay. All right, so you should be thinking, okay, I need y equals mx plus b. How can I get those things? And you might notice that that 0.0 -4 is right down here on the y-axis. Okay. And so because of that, that -4, that place where it crosses the y-axis, that's really your b, isn't it? So if you notice that, you know you got your b. Now 9/7 is not your slope. That's some point way out here, right? You know, your line is going to do something like that, and your job is to try to figure out the equation of that. So if you really like to find the slope by graphing, sometimes the numbers are small enough. You could sketch a graph and then count your rise over run. But the intent on this would be more like this. Thinking about what we did in the last video, getting the change in the y's over the change in the x's. That y2 minus y1 over x2 minus x1. Okay, so just subtract your y's. So the y's, remember, are the second coordinates. So I could do 7 minus -4. Then in the denominator, subtract your x's. Just make sure you start with the same point you used when you did the 7. So that would be this first point, 9, 7. So I'm going to go back there and do 9 minus 0. So I'm working on getting my slope right now. So I'm using the formula. I just didn't want to have to bother plugging in exactly. I know the formula with all the subscripts is really just telling me that I subtract my y coordinates, I subtract my x, and I do it in the same order. Okay, so 7 minus -4, that's really 11. 9 minus 0, you put it right here. That's really 11, and 9 minus 0 is 9. And I can't simplify that anymore, but I'm not quite done. I got to put my two ideas together. So I'm going to come back to this formula, and where the m is, I'm putting 11/9. And where the b goes, I'm putting a -4. But because that's plus a -4, my final way I'm going to write it is 11/9 x minus 4. And there's my answer. Okay. All right, so those first 5 all in some way really gave you the b value, didn't they? Okay. Sometimes they explicitly said it. Sometimes they did because one of the ordered pairs was actually going to be on the y-axis. And that was true for all of these ordered pairs. Okay. And then with this one, you had a graph. All right. Now, the most important problem on this sheet that you need to know, put an asterisk by it, is number 6. Okay. So here's number 6. Put an asterisk by it. Got to know how to do that. Okay. You're looking to write the equation of the line passing through the point -9,5, and it has the slope of -5. Okay. Now, what's different about this from some of the earlier ones, here we have the slope like we did on some of the earlier ones. The difference is this point right here, this -9/5, would be over here somewhere, not on the y-axis. This right here is not a y-intercept. You can't get b just by looking at it. 5 is not your b, okay? All right, so there's a formula we're going to use for this. You need to not memorize this, but know how to use it. I'll be giving you the formulas. So here's the formula for this. It's called the point slope formula. And you'll be given this. It says you can take y minus your specific y coordinate you were given equals m times the quantity x minus the specific x coordinate from the point you were given. And the y and the x, they're going to stay as they are. You're going to plug in your point here. This is where you plug in the point, plug in the coordinates of the point. And then for m, you're going to plug in the slope. You just need to know how to use it and then clean it up a little bit. All right. So the reason I needed something or wanted to use something, there's other ways to do it, but because we have such limited class time, I don't want to show you a ton of different ways. And most people are real successful using this. All right. So if we start out thinking, okay, here's the formula. Think about what you know. You know a point. That's going to be your x1 and your y1. And then this is your m. So in place of m, you're going to put -5. In place of the x1, you're going to put a -9. In place of y1, you're putting a 5. So this is y minus 5 equals the m value and then x minus the x value. The minus here and the minus here, they're part of your formula. This formula right here really comes from the slope formula. So that's why you see those minuses in there, just like you do on slope. Okay. All right, now look, if that makes sense, see what I did? I just replaced the y1 and the x1, and I replaced the m. If that makes sense, you're really home free, and now all you've got to do is work on making this look nicer, cleaning it up a little bit. So first thing I'm going to do is that x minus a -9, I'm going to think of as really x plus 9. Then I see those parentheses, and I'd like to get rid of them, so I'm going to distribute. Because what I'm working on right now is trying to get this into that slope-intercept form, that y equals mx plus b form. I didn't start with it, but I'm just going to clean this up to get there. So now let me add 5, because I'm trying to move across that equal sign, and I have y equals -5x minus 40. So there we have it. Okay. All right, now let's look back at a couple of the earlier examples. That we did without knowing that formula. So what if we had problem number 2? Remember that one? They told me m, and then they told me pass through the point 0.06. You know, I might be used to this point slope formula now that you know it, and you might have just thought, well, that's a point in the slope, so let me just do the same thing here. So in place of the y1, you could put the 6. In place of the x1, you could put the 0. And in place of m, you're going to put the -4/5. Then you're just going to work on cleaning that up. Okay. So then wouldn't we have y minus 6 equals, and here you might either distribute or you might have gone ahead and realized x minus 0 is just x. So you have -4/5 times x, and you need it to be in y equals mx plus b form, so you got to get the y by itself. So you can add 6, and see how that would have got us to the same result as what we got earlier. Okay, it feels a little longer than number 2 did. So it does pay sometimes. If you notice this right here, then that does make the 6 your b. Problem though is on this problem, can you please look at how the 5 right here, that's not b. Do you see why? Okay, because the point -9,5 is not on the y-axis. So it's not, you weren't given the y-intercept. So what I'm saying is if you forget to take advantage of the fact that was the y-intercept, you'll be okay because this strategy would work for that. Did you put an asterisk on number 6? I want you making sure you work problems like that until you can do them in your sleep. And look, if you mess up from here down, you're messing up on chapter 1 and chapter 2 material. Okay. All right. That's why those 2 chapters were so important. We spent a lot of time trying to make sense of them, because once you get plugged into the formula, from there down, it's just a matter of doing some order of operations, some distributing, and then getting that y on a side by itself. Okay. All right. Now let's go ahead then and look at a few more. Okay. I want to look at one more at least, and then I might stop this and do a second video on this that gets into some of the special cases. So let me do this one. I'll stop the video so they don't get too long, and then we'll look at some of the ones that are special cases. Okay. So this time they're wanting me to write the equation of the line, and they gave me 2 points. It kind of goes hand in hand with number 6. Do you see how neither one of those 2 points has an x coordinate that's 0? So both the point -4, -1, and -9, 8 are not on the y-axis. You got a line way over here. You'd have to get all the way to there to have your y-intercept, okay? So you can't just plug in for B. All right, but what you can do is think about that point slope formula that we've been using, okay? So you could plug in a point here, and if you had your slope, you would plug it in there. And they didn't give you the slope, but don't you know how to get the slope? So why don't we just find the slope, then plug into the y minus y1 equals mx minus x1, okay? So that's what I'm going to do. So I'm going to start with finding the slope, okay? So m should be the change in the y's, change in the y coordinates, right, is on top over the change in the x coordinates. So I need to find my slope. So I'm looking at the 2 points I was given, and my y coordinates are the second ones. So I could do 8 minus -1. Make sure you don't say 8 minus 1. It's 8 minus a -1. Okay. And then since I started with the 8 from the first point, then when I go to pick my x coordinates, I go back to that first point and I do -9 minus -4. Okay. Now, it would also be correct, those of you that were thinking about doing it this way, that's also right. Okay. If you had set it up the way I initially did, wouldn't that become 9 on top? And then careful, this is -9 plus 4, that would be -5 on the bottom. Where if you set it up the reverse way with the starting with the second point first, you would do -1 minus 8 and get a -9, and then the denominator would be +5. But see, either way, it's -9/5 for the slope. Okay, so let me just remind you of that and make it big. So the slope is a -9/5. Note that a -9 on top or a -5 on the bottom is equal to the slope overall being negative. These say the same thing, one negative somewhere, okay? Normally you'll write it either this way or that way, either with the negative on top or out in front, okay? Now here's the deal. Now we're ready to plug into the point slope formula, okay? So when we get ready to do that, the -9/5 goes right there, doesn't it? And then you might wonder, well, what do I do about the other thing? I've got 2 points. Well, you just pick one of them. I'm going to show you that it wouldn't have mattered. So just pick one. Pick one point to serve as your x1, y1. So maybe I'll pick the -9, 8 to use for that. Doesn't matter. Just make sure you think about it correctly. So remember how the y and the x, those don't get replaced with anything. So you're going to have y minus 8. Do you see why that is an 8 there, not a -9? You got to put the y coordinate, right? Then x minus -9. -9 goes where x1 was. Okay, so think about that for a minute. Maybe stop the video until that makes sense. Because from here down, I'm just cleaning up the work. So this is y minus 8. This is -9/5, and x minus -9 would be plus 9. Okay, so I'm going to distribute. And I'll have a -9/5 x. And then when you distribute this, just use your fraction keys. Remember not to freak out about fractions. You guys have been doing really well with that. -9/5 times 9, your calculator should give you an 81/5, and it should be negative since this is a negative and this is a positive. Okay. And then at this point, you're going to add 8 to both sides. And when you do, you wind up getting y equals -9/5 x. These have to be combined. You can type in a -81/5 plus 8, just using the fraction keys on your calculator. When you do, if you did it by hand, you'd have to have changed that into a fraction with a denominator of 5. I'm not expecting that. Just use your calculator. Use the fraction keys. And do -81/5 plus 8, and it's going to tell you -41/5. So that goes right here. That's what I get when I combine those. And then that's the equation in slope-intercept form. Okay. Now there are other ways to do it, but I think when we can't be together to really talk through the different methods, I thought it might be best if I just picked the method that most people get through successfully. Now, problems 1 through 7 are kind of a chunk of problems that all go together. Okay. And the first ones that we did, those questions 1 through 5, they all had a y-intercept in them. But, if you didn't know that it was a y-intercept, you would have an alternative, which would be pretty much what we just did here. We would just take that and just plug in what we know. Okay, so let me do one more question from earlier. So remember number 5. Okay, we had the 0.97 and then the 0.0 -4. And when we did it the first time, we noticed that -4 was b. But if you didn't notice that, you would just find your slope. So you might do 7 minus -4 over 9 minus 0. We had to do that when we did it the first time as well. And get your slope. It turns out to be 11/9. Then just go to the formula. So if you didn't notice it was the y-intercept, that's okay. Just go to the formula, plug in a point. It doesn't matter which one. I usually pick the one that doesn't have as many negatives. And make sure you plug in the y-coordinate where the y1 is and the x-coordinate where the x1 is. Okay, and then in place of the slope, we're putting 11/9. Okay, so then we'd multiply the 11/9 throughout, and this happens, 11/9 times 9 turns out to be 11. Then you add 7 to both sides to get the y by itself. Okay, and we'd get y equals 11/9 x minus 4. And there you have it. Okay, so that is an alternative way. That is like if you didn't notice that this was b, but this was really the b. So you also could have found the slope. And if you noticed that was the b like we did earlier, you could put in the m and put in the b and be done. Okay, so math is like that. There's always going to be ways to have really looked at it and approached it in maybe a simpler way. But if you don't see that, you can always just go through this method. This is what you really need to know. Okay. All right, so let me stop this video, and then this is like just how to get the equation of a line and some of the normal situations. Then I'm going to look at a couple of the special ones, okay?